I figured I'd go ahead and get this on film while it works. This is the transmitting section. Spark gap here between these two hooks. Antenna 21 inches. That's the voltage coil and the trigger, which ultimately gets plugged into the wall. Now, some 20-30 feet away rests the receiver. This apparatus here, I know it's dark, it's hard to see this. So what we can do is put the battery in it. And here we have it. See, sometimes it goes off by itself. Maybe it's someone 3 blocks over turning on a light switch or an air conditioner. 21-inch antenna here, all the same. You can see nothing is connecting it anywhere else. It's all by itself. Now, what we can do is send a signal to it. We have to keep the arc pretty small, which is how it sends the most powerful signal. You can see that may still be too large. There. Once it starts picking it up, it continues. So you can see the bell over there. We can control at will. It uses a Coherer type detector with metal filings in it. So you can see it's off, on, off. Let's see. You have to keep adjusting the arc on it. For some reason, these Coherer type receivers really do not like changes in environment. Sometimes it loses its ability to detect the signal, which means it has to be recalibrated. And how you do that is you turn this, let me zoom out, this rheostat into the sensitive position. There. You stop turning when it's on the edge of detecting something. If you turn it too high, the voltage across the detector, this Coherer here, which gets dislodged by this bell arm and feedback mechanism, will not be able to stop it. In other words, the radio waves complete the circuit with this tube here, and the mechanical tapping of this bell, which is the noise mechanism, taps this tube and dislodges the filings. So it works. I'll show you now, and it will work this time. See, you have to be careful about how this thing is adjusted. It's hard to get this thing to accurately work outside, although I swear to you it worked. It worked inside very well. See, the bigger the spark for some reason, the worse. There we go. The worse the reception. I imagine that when these early wireless apparatus were invented in the 1890s, 1900-ish, they weren't much more reliable than this. What I can do now is, so you can see sometimes it picks up spuriously. And you can see it. Oh, there's no one around, and there's no wires linking it to anything, and yet for some reason it picks it up nonetheless. Now, the theory involved is too complicated for tonight, but essentially you have metal filings around a 1/16 or an 1/8 of an inch between 2 screws, and when it receives the impingement of the radio waves, it causes the filings to line up. A drop in resistance is seen, and this triggers the transistor switch, which throws the relay, which turns on the bell, and then the bell dislodges the filings. So the whole process doesn't take very long. See? There. It picked it up. And again, it takes a while to get it going sometimes. But you see, it picked it up, the filings cohered, the bell triggered to dislodge them, it turned it off. In absence of any more radio wave pulses, it remains off. But you can see it's off, on, off, on, off, on, off, on, off, on, off. So you can see it's clearly controlling it whenever you press the switch here, which triggers the spark transmitter. And it keeps ringing because the filings themselves coalesce. Sometimes it takes a second for it to settle down. Now, when it gets to the point when it starts doing what it's doing now, going off sporadically, you have to go back to the rheostat and adjust it, and it stops doing that. I just wanted to make a video reproducing these early wireless experiments. This is exactly how Maxwell's theory was proven, using an apparatus very similar to this one. And you can see it won't go off until we press the trigger. Now, how I believe this works, and it takes a second sometimes, it shoots electricity up and down this antenna here. So it shoots it up and down the antenna, and when this happens, it sends off the wave, which continues over to the receiver, where similar electrical disturbance causes the coherer to coalesce as it does. I find these whole experiments very interesting because before this experiment was done, light was the only way to send a message without wires. Although they used towers like Semaphore in Germany, everything else was wires connected to each other, and this really changed the way the world worked, although it's rather humble by today's standards. There's still not a very good explanation for why the coherer works, and I would show you it, but it's rather annoying. But apparently radio waves can cause filings to line up in strings, the way static electricity does to your arms. I just wanted to document this before this apparatus breaks. Again, I wanted to detect the range of how far this thing could send. I can't imagine it. It sends it too far. But I imagine it goes a block or so. That's it. Anyways, I hope you enjoyed it.